everybody, we are from Group Blue. We are students at UTM for Foundation in Life Science, Section 25. This is our presentation for Intermediate Mathematics, and this is our assignment 1 regarding application of conic section in real life.
Hi, I am Ahmed Ali Asaya.
Hi, I'm Pritika Ramu.
Hi, I'm Durgashna Varshaini.
What is parabola? A parabola is a continuous curve that looks like an open bowl where the sides keep going up infinitely. It's defined as a set of points in a plane which are equidistant from a straight line or directed and focused. Its formula can be represented as y equals x to the power of 2. It's part of the conic section as shown in figure 1. Some facts about parabola. Apollonius of Perga, 3 BC, a Greek mathematician, is credited with naming the parabola. He writes from the Greek word exact application, meaning the application of a given area to a straight line. Parabolas can be seen in nature or in man-made objects, from the fast-growing big wall to satellite dishes to fountains. This geometric shape is relevant and even functions to help focus light and radio waves. Parabola rules. Quadratic functions are all of the form fx equals ax squared plus bx plus c, where a, b, and c are known as the quadratic coefficients and are all real numbers. Each quadratic function has a graphical representation of the xy grid known as parabola, which its equation is y equals ax squared plus bx plus c. They are either concave down. They all have a y-intercept, a point at which the parabola crosses the y-axis. They all have a vertical axis of symmetry, whose equation is x equals negative b over 2a. They all have a vertex, a minimum or a maximum point.
This is the example of problem statement. Find the x and y intercepts, the vertex and the axis of symmetry of the parabola with equation y equals to negative x squared plus 2x plus 3. And this is how you solve the problem. First, the x-intercepts are the intersection of parabola with the axis, which are points on the x-axis, and therefore their y-coordinate are equal to 0. Therefore, we must solve the equation 0 equals to negative x squared plus 2x plus 3. Second, we have to factor both sides. Third, we have to solve the x-intercept where x equals to 3 and x equals to negative 1. Then, the y-intercepts are the section of the parabola with the y-axis, which is a point the y-axis, and therefore its coordinate is equals to 0. After that, the vertex is found by writing the equation of the parabola in vertex form, which is y equals to a bracket x minus h square plus k. By using the completing method, we can identify the vertex values, which is h and k. And therefore, vertex point is bracket 1, 4 and 1, 4. To prove the statement, we can draw a graph where you can see the vertex form is y1, 4 and the coordinates are negative 1, 0 and 3, 0.
Here are some example of it. The shape of a banana is parabolic. Surface of concave mirror also parabolic. Dish attendants take the shape of parabola too. Here are some examples based on real life. Imagine you are designing an archery range and you want to create a target area where archers can practice hitting a bullseye. To make it challenging, you decide to set up a parabolic obstacle in front of the target. The equation that we use is y equals to ax squared plus bx plus c. Y is the height above the ground, x is the horizontal distance from the starting point. A, B, and C are constants that determine the shape and position of the parabola. Given A equals to 0.02, B equals to 0, and C equals to 4. If an arch stands 10 meters from the starting point, you can calculate the height of the obstacle at that location using by substituting the given A into the equation. So you'll get the answer whether it's 6 meter. Let's go to example 2. Imagine you are an engineer working on project to design a suspension bridge. One critical aspect is determine the shape of the bridge main supporting cables. The shape of these cables should form a nature curve and parabolic equation can be used to model their shape effectively. The same equation is being used, and in this, y is the vertical position or height, x is the horizontal position along the bridge, a, b, and c are constants that determine the cable's shape and position. Given a equals to 0.001, b equals to 0, and c equals to 40. By substituting into the equation, you will get answer 40.4 meter.
How and why? Parabolas in engineering and architectural applications. Parabolas are used in architectural and engineering applications such as suspension cables, which are parabolic in shape. They are used because they uniformly support a bridge. An example is the iconic Golden Gate Bridge in San Francisco, California, which features the parabolas on either side of its side spans on towers, as shown in Figure 2. Here we can see the Golden Gate Bridge and the Gateway Arch, which are both parabolic in shape.
Okay. How and why in parabolas in concave mirror? Concave mirror helps converge light because of its parabolic shape. We use concave mirror to converge light signals such as headlights and satellite dishes as shown in figure 3. As you can see, light rays passes through A and reflects in the mirror towards B and also reflects towards E and reflects back towards C. Therefore, parabolic shape or curve shape is formed when you observe.
As a conclusion, parabolic equations are essential mathematical tools used in various applications. They are represented in the form y equals to ax squared plus bx plus c, where a, b, and c are constant, defining the parabola shape and position. These equations are employed in fields like physics, engineering, and sport to model trajectories, design structure, and solve optimization problems. They enable us to create aesthetically pleasing designs like suspension bridge cables or archery range obstacles, making them invaluable in real life scenarios. That's all from Earth. So, anyways, thank you.
Thank you.
Thank you.